Good day. Today we're going to look at the solution, the complete solution to yourturn3. It's the third in the series of chi-square problems from your chi-square notes. So let's have a look. How are smoking habits of students and parents related? Does a parent's smoking habits affect their child's smoking habits? Consider the data from 8 local high schools and perform a test for independence. Use a 1% level of significance. So you can see the data gathered, whether a student smokes or not, and the other variable is whether both parents smoke, one parent smokes, or neither parent smokes. So what we need to do is test this for independence, right? So as a contingency table, this is called a contingency table, relating one variable to another, and we want to see if those variables have an association, a relationship, okay? So we're going to use the 5-step process, all right, and let's get started. So the first thing we're going to jot down here is our null. The first step, as you know, is the null and alternate hypothesis. So let's have a look at that. So step 1. Alright. Now, so what is the null? H0, and what is the alternate? H1. What are these hypotheses? Okay. So the null hypothesis, basically, we're going to say there is no relationship, right, between. Okay, so we'll just jot between the smoking behaviors of parents and students. So let's write it like that. There is no relationship or no association, I guess you could say, between parents' smoking behaviors and students. Between parents smoking, parents and students, or the child, assuming that's their child, obviously, students. Smoking behaviors or smoking habits, or so let's write down smoking habits. Okay, now the alternate hypothesis, of course, is going to be what? It's going to be that there is a relationship. So there is a relationship between parents and students smoking habits. Okay, so I'll just put the dittos there for that. So you got the idea, right? Now step 2 is status and a level of significance, and that's already done for us. We don't have to worry about that. So alpha is 0.01. Okay, step 3 is choose your test statistic. In this case, it's going to be a chi-square test of independence. Test for independence. And that's another way we could have said the null hypothesis, right? That these variables, whether a student smokes and a parent smokes or not smokes, are independent. So we could have said the null and alternate in that form. But basically, that's the easiest way to start. There is no relationship between the two variables. There is a relationship. Is the easiest way to start with your null, excuse me, and alternate hypothesis. Now, step 4 and 5 is where most of the work takes place, obviously. So chi-square critical value. Okay, now, and then make your decision rule. So the chi-square critical value, now you see the chart I have up above to the right. Alright, and you can see that I have chi-square critical value marked in right there. Now what is that critical value? And what does this chart mean again? It means, remember that chi-square distribution is always a right-tailed test. Okay, so this area here is, of course, where we're going to reject the null hypothesis. Okay, so if it's chi-square, critical value is right here. Anything greater than that we'll reject. Anything less than that, of course, do not reject. Now, some people say accept, but the proper words are do not reject, because we necessarily don't accept depending on how strong the rejection is or not. So do not reject the null hypothesis if it's less than. So what is the chi-square critical value? Well, in order to do that, we need to know the degrees of freedom. Now the degrees of freedom from a contingency table is a little different, right? It's the number of rows minus 1, okay, times the number of columns minus 1. Okay, so in this case we have 3 rows. The rows are horizontal, so 1, 2, 3 rows. 3 minus 1 times number of columns, and you can see we have 2 columns. Do not include totals, of course, when you're doing this. So that's 2 times 1, or simply 2. So the degrees of freedom is 2. Now if you're doing it on the calculator, of course, it'll also calculate that for you when you enter your data in. Now, we need to know the critical value at a 1% level. That comes from a table. So let's bring up the table here now. So you can see the table. So we're doing a 0.01 level of significance. So let's see if we can find that. 0.01 level of significance right here. And our degrees of freedom is 2, which is right here. Okay, so we can see that our critical value is 9.210. Now, make sure I got that right. Going down on the column across with 2, yeah, 9.210. Okay, so that's our degrees of freedom. Or that's our critical value for chi-square. So that's this value right here, 9.210 on our chart. Okay, so what does that mean for us? Well, that means our decision rule becomes what? So decision rule is if chi-square test value, which will compute in step 5, is greater than 9.210, then we are going to reject the null hypothesis and accept, of course, the alternate hypothesis. Okay? Now, if you're using just the p-value test only, which is the probability that this test statistic is correct, the chi-square test, we write our decision rule: if p is less than alpha, then reject HO. Now alpha in this case, of course, we could write that in if we want. Instead of saying alpha, we could actually write the value in, which is 0.01, right? So p is less than 0.01, then reject HO and accept accept H1. Now HA is just another, some people use HA as the alternate. Okay, so there you go. There's your decision rule and your chi-square critical value. We're all set to go. Step 5, of course, brings us to chi-square test value. Let's look chi-square test value. Now how do we get the chi-square test value? Okay. Well, first we're going to use a calculator to do it, and to enter the data from a contingency table into the calculator, we use a matrix function. We set it up as a matrix, okay, which is rows by column. See matrix above the x to the minus 1 button? See the blue one? So second, and hit the x to the minus 1 button, which brings you to matrix. Arrow across to edit. So we're going to edit matrix A. Now matrix A is asking you, see the cursor blinking above the first number. The number of rows always comes first. Now we have how many rows? We have 3. So put down 3, enter. How many columns do we have? We have 2 columns. Remember not to include totals. So there's your 3 by 2 matrix. Now enter each cell. So see the 400 in the cell over here, that goes in first. Then it goes this way. It'll go to this number next as you hit enter. So I'm going to enter those now. 400, hit the enter button. 1380, enter. 416, enter. 1823, enter. 188, enter. 1168, enter. Now always take a second to check your data, double check and make sure all your numbers are correct, which is what I'm doing now. 400, just double checking to make sure all my data is correct. It is. So next you go to stat mode, and of course we're over to tests. When you run a test, you know all the tests are here. And this is the chi-square test for independence, which is C:, different than chi-square goodness of fit test, which we've done in previous examples. Okay, so we're into C:, chi-square test of independence. Okay, now enter. Now the first thing is asking you, is the observed values in matrix A? Yes. the expected values will be automatically computed and placed in matrix B, and you can look at that later if you want. Okay, but the observed values are in A, the expected values are in B. So that's all you got to do is put it in matrix form in matrix A and tell the calculator it's in A, which it is, and now calculate. And you can see our values. The chi-square number is very large, 37.56. So let's jot that down right away. Chi-square test of independence, the chi-square test value is 37.57. We'll round off to 2 decimal places. Okay, and we might as well jot down the p-value while we're here. Now look at the p-value. Be careful on your calculator. That's not 6.95. Look at the very end. E to the negative 9. That means there are 8 zeros in front of that. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Then 6, 9, or 696, which basically we can write as 0. Okay? So the chi-square, or the p-value for the chi-square test here is basically 0. Okay, and notice it also gives us the degrees of freedom. df is 2. We calculated that earlier. It matches what we said. The degrees of freedom is 2. Now, let's draw our conclusion. Okay, first let's do the chi-square test value. Now look at the chi-square test value. Put this value up in your chart. Well, it's way up here somewhere. It's definitely in the reject region, right? Because chi-square test value is greater than 9.210, right? It's greater than 9.210. Therefore, reject the null hypothesis and accept the alternate hypothesis. Now, the p-value test should give us the same conclusion. Let's go over to the p-value. 0. Is p less than alpha? Is 0 less than 0.01? Oh yes, and right, as we know it is indeed, and therefore the same conclusion. Reject HO and accept H1. Now, what does H1 tell us? Well, there is a relationship or an association between behaviors, smoking behaviors of parents and children. Okay, so there is a relationship. And we can say it is reasonable to say in front of this, right? Or data suggests that. So there is a relationship. Oops, let's get the spelling right there. R-E-L, a relationship between smoking habits of parents and children. Okay? And there's your conclusion. So hopefully that helps. That's it for now. Check out the next videos now in the next section as well. Over and out.